Hey, 8th graders. Today is the last lesson that we're going to do in this unit so far. So we're going to kind of put together the rest of our pieces for our little Australia mystery. And I think you guys, for the most part, have a pretty comprehensive picture, but there's still one aspect that we really need to look at. We kind of narrowed it down to two claims that people in Australia are a little bit more prone to skin cancer. And we haven't talked a ton about that, but we did do a little research on melanin and found out that, yes, melanin protects our DNA and our cells. And yes, Australia has a little bit lower amounts of melanin in their skin than other countries like Brazil. And we also looked at I think that was actually claim 3, but claim 2 then was that there's something different about the sunlight that reaches the earth in Australia. And we did find that Australia has a little bit higher UV light concentration than other places like Brazil, which also gets the same amount of sunlight but has less UV. So that's what we're going to kind of focus on today. So your learning targets are, I can model what happens to light when it hits different molecules in the atmosphere, and use this to explain why more VU light reaches Australia. So we're really going to focus in today on different molecules that we see in the atmosphere and how UV light interacts with those. Okay, so we're going to go ahead and move on to your warm-up for today. What's in the atmosphere? So Earth's atmosphere is made up of gases like oxygen, nitrogen, carbon dioxide, and ozone, as well as some tiny liquid droplets such as sulfuric acid. When light from the sun passes through the atmosphere, it can hit these materials. Different things can happen to the light depending on the type of light it is and the type of material it hits. So we kind of learned the different pathways we can see light take. It can either be absorbed, and you guys will see the energy be absorbed, or it can be transmitted where it goes straight through, or reflected where it bounces off. And in those two cases, we don't see any of the energy being absorbed. Okay, so those are some options that we're seeing so far with the pathway of light, and now we're going to see what happens when light hits these molecules. Do they absorb, transmit, or reflect? Okay, so you should answer this question. What are some things that might happen to light when it hits different materials on its way through Earth's atmosphere? Well, we just kind of talked about that. Okay, if you need to take a second, pause this video, finish up the warm-up, and then we'll move on to activity 2, which is the sim, and you guys are really going to dig in and get some data in this sim. All right, so there's 3 specific molecules that you guys are going to be looking at in this sim. Ozone is the first one of these. So investigating ozone. Ozone is a gas found in the atmosphere. The Australian Health Alliance thinks that ozone might have an effect on skin cancer rate in Australia. How do the different types of light emitted from the sun interact with ozone? So you guys will kind of be answering this question first, making a prediction on what you guys think ozone does and how it contributes to this. So you guys will first make a prediction. You have different types of light will interact with ozone in the same way because all light is the same. Or you might think that different types of light will interact with ozone in different ways. Okay, so remember, we are just going to be focusing on UV light, but we are still going to look and see, all right, what are some other interactions we might see with like gamma rays, radio waves, visible light, those kinds of things. Okay. All right, next little one is sulfuric acid. So sulfuric acid is found in the atmosphere in the form of tiny liquid droplets. The Australian Health Alliance thinks that sulfuric acid might have an effect on the skin cancer rate in Australia. How do the different types of light emitted by the sun interact with sulfuric acid? So again, same thing here. All types of light will be absorbed by sulfuric acid. All types of light will be transmitted by sulfuric acid. Again, this is a prediction, so do you know? No, but make a guess. Okay, all types of light will be reflected by sulfuric acid, and then different types of light will interact with sulfuric acid in different ways. So again, we're not just looking at UV light, we're looking at the full spectrum from gamma rays down to radio waves. Okay, so how do you think they're going to react? Okay, and then finally, the last molecule we're going to look at is carbon dioxide. So carbon dioxide is found in the atmosphere as a gas. The Australian Health Alliance thinks that carbon dioxide might have an effect on the skin cancer level in Australia. How do the different types of light emitted by the sun interact with carbon dioxide? So again, we're going to use the sim to kind of see how light interacts with carbon dioxide. So first, make a prediction. All types of light will be absorbed by carbon dioxide. All types of light will be transmitted by carbon dioxide. All types of light will be reflected by carbon dioxide, and different types of light will interact with carbon dioxide in different ways. Again, we're not just going to be looking at UV, we're going to look at all the types of light. So how do we think they might interact with carbon dioxide? Okay, moving on to the sim, I kind of just made you guys some generic instructions here. So you'll need to open the Lightwave sim. Here's your guys' link. You guys need to make sure you're in complex mode. Okay, so when you guys open this up, you guys should open to complex mode. But what we see in complex mode is we have a whole wealth of items that we can test, including sulfuric acid, carbon dioxide, and ozone. Okay, we're going to start by dragging ozone to our platform here, and I'll kind of do this one for you guys. Ozone is basically 3 oxygen molecules bonded together, so you guys can kind of see 1, 2, 3 oxygen molecules. Okay, and we're going to set the sun source to sun and turn it on. So I'm going to again kind of do this for you guys. I want the sun. I'm going to turn it on. And then what I can see here is it looks like the only thing that happens with ozone is that we're going to have probably some absorbed and some that are transmitted straight through. So if I click on this, this is the light before it hits ozone, and this is the light after it hits ozone. So basically, this light here, visible and radio, can transmit through ozone. The rest are all going to be absorbed. So what I'm going to do is I'm going to go into my ozone graph, and I'm going to say, all right, the only 2 in this case that were actually transmitted through are visible and radio. So I'm going to go ahead, grab my draw tool. I'm going to use a highlighter, and I'm going to say visible is transmitted and radio is transmitted. Okay? If I look back at my sim, there's nothing bouncing off here, so that means I'm not going to have any reflection whatsoever with ozone. That means the rest of these gamma rays, X-rays, ultraviolet, infrared, and microwave are all absorbed. So the rest of these are all going to be absorbed. Gamma's absorbed, X-rays are absorbed, UV rays are absorbed, infrared's absorbed, and microwaves absorbed. So the only 2 I have here that are transmitted are visible and radio. Okay, the rest are all absorbed. Okay, so visible light can go through ozone and hit the Earth's surface, and radio waves can go through ozone and hit the Earth's surface. Okay, I'm going to do the same thing, except I'm going to click and drag sulfuric acid up there next. So record your data, repeat for sulfuric acid, and then carbon dioxide. So you guys will go ahead, do the same thing. You guys won't necessarily see either. You guys might even see some that are absorbed, some that are transmitted, and you might even see some that are also reflected. So make sure you guys kind of pay attention to, all right, these ones are reflected, these ones are transmitted, these ones are absorbed. So you guys can kind of compare by clicking on all the beams. If you guys have one that's reflected, you can click on that as well and see, all right, these types are the ones that are reflected. If you click on the light that comes out the other side, those are the types that are transmitted, and then anything else is absorbed. Okay, any differences that you guys see here is absorbed. Okay, all right, so go ahead, complete that for sulfuric acid, and then complete that for carbon dioxide as well. Go ahead, take a second to pause that and complete through slide 10. Okay, slide 11 is a little review for you guys. So when sunlight enters the Earth's atmosphere, gamma rays and X-rays are absorbed. So we kind of saw that a little bit in our sim data, is that gamma rays and X-rays got absorbed a little bit. Okay, that leaves 5 different types of light that can make it all the way to our Earth's surface. So what we're going to look at is, of these 5, we're going to kind of just review which one of these actually is damaging to the cells. So if you guys kind of remember, we can go back into our sim and check those. Okay, so I'm just going to go ahead and do my laser. I'm going to set it first to, I don't even need to test gamma, ultraviolet, and then remember we're looking at DNA. Okay, I'm going to turn it on, and then I'm going to, oops, that's not DNA. Sorry. I'm going to turn it on, and then I'm just going to kind of see, all right, with UV, we saw damage. Okay, now let's change it to, let's see here. Where is ultraviolet? Let's just do a visible light, inspect, no change. Okay, and then infrared, inspect. We're going to increase the kinetic energy, but no damage. Then microwave, inspect, no change. Radio waves, inspect, no change. So the only one that actually damaged the DNA was the ultraviolet light. So we just kind of did this, which one of these 5 caused damage to genetic material. So from here on out, we're just going to focus on the UV light, which we already kind of knew that that was what causes damage. Okay, so based on your investigation, so if you guys need to look back at your data tables, which I'm assuming you guys might need to, Okay, you guys are going to answer these questions. Based on your investigation, could the amount of ozone, so either having more or less ozone in the atmosphere, be a factor in why Australia gets more UV light than other parts of the world? So again, look back at slide 8, which shows you guys your data for your ozone, and look and say, all right, could this be a reason, like is UV getting past ozone? Okay, could having more of it or less of it cause more UV lights to hit the earth in Australia and cause skin cancer? And then explain your answer. Okay, same question for sulfuric acid. So again, look back at slide 9, which is your data table for sulfuric acid. When UV light hits it, so focus just on UV light, okay, what happens when UV light hits your sulfuric acid? So could that be a reason that there's higher skin cancer? So again, either having more or less of that. Okay, so we're just saying different amounts. So based on your investigation, could the amount of sulfuric acid in the atmosphere be a factor in why Australia gets more UV light than other parts of the world? So again, we could have more sulfuric acid or we could have less sulfuric acid in the atmosphere. So could that be some factor that causes more UV light to get through? Explain your answer. And then finally do the same thing for carbon dioxide. Based on your investigation, could the amount of carbon dioxide in the atmosphere be a factor in why Australia gets more UV light than other parts of the world? So if we have less carbon dioxide and less, either more carbon dioxide or less carbon dioxide, if we look back at our data on slide 10 for UV rays, okay, could having either more or less carbon dioxide cause more UV light to get through and to harm our skin? Okay, so answer those questions, and then once you guys are done with slide 14, okay, we'll go ahead and move on. So pause this video right now and complete through slide 14. Okay, so as you guys look at this, we kind of saw that, all right, when ozone hits it, okay, what happens to it? So you guys will click and drag, either reflects, transmits, or absorbs to label each of these boxes. Okay, so what does ozone do when it hits it? What does sulfuric acid do when it hits it? And what does carbon dioxide do when it hits it? Okay, so what we find out with this is because carbon dioxide UV light transmits through carbon dioxide, it doesn't really matter how much you have. Okay, so you can have more carbon dioxide, you can have less carbon dioxide, but that's not going to change the amount of UV light that hits the earth, because no matter what, UV light's going through it. Ozone and sulfuric acid could be a part of this. Okay, so we're going to kind of dig a little bit further into what the atmosphere over Australia looks like as far as the amounts of ozone. Okay, obviously if we had more sulfuric acid, that would actually be good because it would reflect more of that UV light away from the earth. Okay, however, if we have less sulfuric acid, then we would have less reflection of that UV light and more would reach the Earth's surface. And then obviously UV light is absorbed. Okay, so by ozone, so if we have more ozone, that's good because more UV light's absorbed. If we have less ozone, that's bad, meaning that more UV light could potentially not be absorbed and get through to the Earth's surface. Okay, so here's some data that we found about the atmosphere in Australia. So the Australia Health Alliance has sent some new evidence about the atmosphere over Brazil and Australia. Discuss this evidence with your partner. Use the questions below to guide you. Obviously, you're working from home, so you have no partner. What is different about the atmosphere above Brazil compared to the atmosphere above Australia? Does this difference help explain why Australia gets more UV light than Brazil? If so, how? Okay, so amount in atmosphere above the country. So Brazil has more ozone than Australia. Sulfuric acid, Brazil and Australia actually have the same amount, and as we found out, carbon dioxide doesn't matter because the UV light goes straight through it anyway. Brazil and Australia have the same amount. Okay, so what you guys are going to do is do a little modeling tool. Okay, you guys have basically this line here that separates. This is one country, this is the other. So the first thing you guys will need to do is figure out which one's Australia and Brazil. If you guys need to review back to this data, okay, they do not have the same number of each molecules. So use this little key, count up how many you have, and then I just identify, all right, which one of these atmospheres represents Australia and which one represents Brazil, and then drag your guys' label to show me which is which. Okay, so that's the first thing you guys need to do. Once you guys have determined which side's Australia and which side's Brazil, then you guys will move on to number 2 in your guys' little directions over here. Use the draw tool to trace the pathway of UV light to Earth's surface. Okay, so that pathway for now is going to be in a straight line because we know that light travels in a straight line. So if a molecule gets in the way of one of these UV lights, there's 6 that you guys are going to trace. Okay, let's take, for instance, carbon dioxide. So let's look at this one here. If I hit a carbon dioxide molecule. I know that UV light goes straight through it. So I'm going to draw an arrow all the way down. It didn't run into anything else. That's about as straight as line. If you guys wanted, you guys could go to shapes and do an arrow as well and kind of do it that way and be like, all right, here's my arrow. It's going to continue. Oh, shoot. Sorry, guys. Now my computer's being really slow. So I could do it this way and say, all right, here's my arrow. It's going to go straight through. Oh, I'm struggle busting, guys. This arrow is going to go straight through this carbon dioxide. Okay, so that would be my arrow going down. So that shows me that, you know, when this light wave hits this carbon dioxide, it goes straight through. Okay, so if a molecule gets in the way, model how the light reacts with that. So if it reflects, show that arrow reflecting and bouncing back up. Okay, if it transmits, that arrow is going to go straight through. And if it is absorbed, then that arrow is just going to stop at that molecule. So again, you might need to review back on slide 15 to see what happens for each of those 3 different molecules. If no molecules get in the way, that UV light is going to reach the Earth's surface. So at the end of this, you're going to look and say, all right, which one has more arrows reaching the Earth's surface? Okay, based on what happens, like this UV light's going to hit this sulfuric acid, so what's going to happen to it? This one's going to hit this ozone, what's going to happen to it? This one's going to hit this carbon dioxide, what's going to happen to it? Okay, so you guys are going to kind of count and figure out, you know, which one's Australia, which one's Brazil, and then how many UV lights are actually reaching the Earth's surface and how that might contribute to our cancer rate in Australia. Okay? Go ahead, take a second, pause this video, finish up this modeling tool through slide 17, and then we'll move on to our last activity. All right, so last activity is writing. So you're going to write an argument about Australia's skin cancer rate. In class, we did this as a little group activity. Obviously, you guys at home are going to be flying solo on this. So now you have enough evidence to explain why Australia's skin cancer rate is so high. Review your argument from chapter 2 and think about how you will convince the AHA that both claim 2 and claim 3 are accurate. So remember, claim 2 is that there's something different about the light, which we know is a little bit true based on what molecules we have in our atmosphere. And claim 3 was that people in Australia don't have, they have skin that's more susceptible to skin cancer. So think about what we learned in chapter 2 about that as well, okay, as far as melanin goes. You will use your completed reasoning tool from activity 3, which we didn't do, to revise and add to your argument. If you would like to write a new argument, you may delete your old argument before you begin. You guys are starting from scratch, so I wouldn't worry about any of that. Okay, just to revisit claim 2, there is something different about the sunlight in Australia. Fair. Okay, claim 3, more people in Australia have skin that are easily damaged. So I want you guys to talk about both of those claims because there's some truth in both of them. Okay, so your argument should be about 5 to 7 sentences long. Again, make sure you guys address both claims 2 and 3 and write me an answer to the question, why is the skin cancer rate so high? Okay, read through it, proofread it, make sure you guys did a good job. Again, you should have 5 to 7 sentences. I'm going to be grading this kind of harshly, so make sure that you guys do a good job and put some effort in because your grade for this assignment will rely in good portion on what you guys write in this last paragraph. Okay, finally, finish your wrap up. Do you have any questions, yes or no? If yes, type them there. And then 4, 3, 2, 1, how do you think you did? Make sure it saves. Go ahead and hand it in, and you guys are all done. I hope you're having a great day. Bye.